In this demo, I'll be showing you how a trait can be created and utilized. I'll start by creating my trait. I'm going to create a trait that represents something falling. I'll use the trait keyword, and I'll call the trait fall. I'll create a function within this trait, and I'll name it hit ground, and it won't return anything. We'll just print messages for this demo. We then need to create some data to work with. So I'll start with a vase. To implement functionality for a trait, we just use impl fall for vase. We then need to ensure that we implement this function since it's part of the fall trait. If we fail to do so, we will get a compiler error. So we take the function, and I'm just going to print out the vase broke. Next, I'm going to create some more data. This can be a cat. I'll implement fall for the cat structure. Again, we just have to implement that specific function since it's the only one with the trait. And for the cat, we'll print out the cat casually walked away. Next, I need to create a function that utilizes the trait. I'll call it fall. Notice that the trait starts with a capital F. Traits should always start with capital letters to distinguish it from functions. Our function is using all lowercase because we usually use all lowercase with function names. The fall function will take an argument of thing, and the thing will implement the fall trait, and we'll just call thing.hitGround. Lastly, we need to call our fall function, and I'll do so with a vase and then a cat. We'll just create a new vase, and then we'll create a new cat, and that will be our program. I'm going to step through the program so we can see how it works. First, we are defining a new trait using the trait keyword. Our trait name is fall. It only has one function, and that's called hit ground. So whenever this thing falls and hits the ground, this function would be called by the program. We then have a vase structure, and to implement this trait on the vase, we use impl fall for vase. So it's implement the name of the trait for the thing you're implementing the trait on. In the implementation body, we simply need to have the function hit ground, since that's the only one that's in the trait. And for the vase, we're just printing out the vase broke. The same goes for the cat. We have a cat structure. We're implementing fall functionality for the cat. When the cat hits the ground, it just casually walks away. Next, we have our fall function, and it just takes anything. So I just named it thing. Usually, if something is falling, it's probably a physical object, so thing seemed appropriate. As the type of thing, we use the impl keyword to specify that we're relying on something that implements functionality, and the functionality that we're implementing is fall. So our thing must implement the fall functionality in order to use this function. In our function body, we're just taking that thing and calling the hit ground function. The hit ground function is guaranteed to work with this particular function because we specified that the thing must implement the fall functionality, and the fall functionality is defined here in the trait body. If we failed to implement the fall functionality on something that we sent to this fall function, so if we sent in a string here or a number, we would get a compiler error since we did not implement fall on a string or a number. Finally, in our main function, we are calling the fall function 2 times, one with a new vase and one with a cat. When we run the program, it should print out the vase broke and then the cat casually walked away. Let's run it and confirm that's what we get. And there we go. The vase broke and the cat casually walked away. As you can see with traits, they allow you to easily share functionality between vastly different types of things. In this case, we have a vase and a cat, which are completely unrelated, but they both can fall and hit the ground. So now we have shared functionality via the trait, and they both can fall and they both can hit the ground. And when they hit the ground in their own specific ways. We don't have to worry about how these ways are implemented. We just need to know that it does implement some way to do it, and then we can utilize that implementation within our program. This concludes the demo on traits. I'll see you in the next presentation.